Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 15 of a unit motion in a straight line. So let's begin with today's class. Today we are going to discuss about the motion under gravity for a freely falling body. In the previous class, we have discussed about the basic formulas of the motion under gravity, that what should be done when object has been thrown in upward direction, what should be done by us when object has been freely fall, and that all kind of stuff. Today we are going to discuss about the some very good applications based on this concept only. So let's begin with today's class. But before we start, I request you to please go through the previous lecture if you have not. So pause this video and go for it. And and if you have done it, please have your pen and paper, and you are going to solve these questions with me, along with me, and then we are going to matching the answers and the class will be proceed. Yes, are you ready with this? So let's move on. Suppose the question is, if an object is in a free fall motion from certain height, then find out distance traveled by an object in first second to third second. One more thing, assume that it has been dropped from height h. Yes, this is what all they have provided, as well as I can take g is equals to 10 meter per second square. Yes, so look at the data. What they said is that an object is there which is having a free fall motion from a certain height. I need to find out the distance traveled by an object in first second to third second. And they also mentioned that it is in it has been dropped from certain height h, and I can take a g is equals to 10 meter per second square. So what can I do? What is going through your mind? How will you do this? Any clues and any ideas? Yes, so let's move with this. Let's say this is height h, and from this height h an object has been released from this. It has been dropped, that means u is equals to 0 meter per second initially. You need to find out the distance travel is first, second and third. Let's say this is first, this is second, and this is third. Yes, so what I can do is distance traveled in first second, this is equals to, my relation was ut plus half gt square. As I know u is 0, so this is having only a half into g into t square. So this is equals to 1 by 2 into 10. As I want to find out in the first second only, it's a 1 square. So this is equals to 5 meter. Yes, this is h1. Now what about the third seconds? What about the third second? How could I find it out? Yes, yes. If I find it out for the first 3 seconds, and then I will subtract in 2 seconds, then I can have a data of third second. So let's say what I want is that let me do this h3, that is from 0 to 3 seconds, and then I will find out the h2. It's 0 to 2 seconds, and then I will subtract from h3 to h2. So first let's find it out. h2, it's again half into g into t square. I'm directly writing this because I know that u is equals to 0. So this is equals to 1 by 2 into 10 into 2 square, it's a 4. So this is 1 by 2 multiplied by 10 multiplied by 4, and this would be a 20 meter. And last, it's an h3, it's a half into g into t square. So this will give me an 1 by 2 multiplied by 10 multiplied by 9. It's a 2 5s are 10, and this is 45 meter. So now I want in third second. So height or distance traveled in third second would be equals to h3 minus of h2. It would be a 45 minus of 20, and that stands to an 25 meter. Yes, what did I find? What I require? That the distance traveled by an object in first second to the third second. Okay, so first to the third, I require a ratio of the first second to third second. So what I can do is, it's in h1 is to h3. h1 is 5 meter, h3 is 25 meter. So this is 1 is to 5. This is one of the approach. This is one of the approach. Have you done the same thing? Did you? Yes? Let me show you one very good approach to solve this. Let's have an alternate method of this. Let's revisualize the situation that this is height h. An object has been dropped and it is traveling a certain distance, something like this. So what I know all this, that a first thing, its initial velocity is 0. A second thing that its acceleration, which is equals to g, which is constant. And the third thing, that time interval remains the same, because this is a 1 second, again this is a 1 second, again this is a 1 second. So the time interval remains the same, initial velocity is 0, and your acceleration is constant, which is a is equals to z. Yes, so according to the Galileo's law of odd numbers, yes, according to the Galileo's law of odd numbers, you can write like this: if it is x, this should be 3x, and this should be 5x, and onwards if they have been asked for. So I know that for the first second, a distance traveled by an object is always 5. If you don't remember this, just go for it and calculate this. H is equals to half gt square. So that would be equals to half into 10 into 1 square. It's a 1 only. That would be a 5 meter. So this is distance traveled in first second. Now distance traveled in second. Let's say this 5 as an x. So this is equals to 3 into 5. That would be a 15 meter. Let's say distance traveled in third second, it would be a 5 into 5, it's a 25 meter. Yes, and then you can have a ratio of this, it's an h1 is to h3. This is equals to 5 is to 25, and that tends to 1 is to 5. That's it. So this is more faster approach. You must remember this, that when object is being dropped, that means its initial velocity is 0. It is traveling under gravity only, that means it's a is equals to g, which should be a constant, and the time interval remains the same. If this is the situation, if this is the situation, then I can always go for the Galileo's law of odd number, which gives me a 1 is to 3 is to 5 is to 7 is to 9 and onwards. Yes, this would be the thing. Yes, can you do this? Okay, great. Let's move to the next question. Go through the data very quickly. What they have given. What they have given is velocity of a freely falling body after t seconds. It's a 49 meter per second. Its velocity after t plus 2 seconds will be in meter per second. What they have given is that it's a freely falling body. They have clearly mentioned this. It's a freely falling body. That means they are having an initial velocity as a 0, and they have not given that take a g is equals to 10 meter per second square. So I should go with the g is equals to 9.8 meter per second square. They have given me the final velocity of 49 meter per second, but when t is equals to t. So let's just find it out, that what should be the value of t. It's a v is equals to u plus gt. This u should be a 0, g should be equals to 9.8 multiplied by t, and this is 49. So if I solve this, the t should be is equals to 49 by 9.8, or I can write like this: 49 by 98 multiplied by 10. Yes, then 49 2s are 98 and 2 5s are 10. So this is the situation when t was the 5 seconds. Yes, so 49 meter per second, it is the speed when t is equals to 5 seconds. Yes, now you require an velocity at t plus 2. Now you require an velocity at t plus 2. How could you do this? How could you do this? So what you can do is, it's in v is equals to u plus gt. This is equals to 0, plus g would be equals to 9.8 multiplied by 7. So this is simply the 98 multiplied by 7 divided by 10 meter per second. I hope you can do this. Will you be able to solve this? Are you are you sure? Calculate it and give me the answer. Yes, it is 68.6 meter per second. This would be the final answer of mine. Yes. What was yours? Is it same? Great. Let's move to the next question very quickly. What they have given, a body dropped. That means they have mentioned that u would be 0 from a height, reaches the ground in 5 seconds. Okay, the velocity with which it will reach to the ground. Again, they have not mentioned that g is equals to 10 meter per second square, so I need to go with the 9.8. What I require velocity. When I require, it's a t is equals to 5 seconds. Yes, it is somehow previous question only. It's an v is equals to u plus gt. This u would be equals to 0. G is the 9.8 multiplied by 5 seconds. So this 9.8 into 5, it's in 49 meter per second. That's it. Yes, it's in question of 2 seconds. Yes. What was your answer? Did you do the same thing? Do you feel comfortable with this? Are you sure? Questions can be done. Can it be? Yes. Let's move to the next question and do this very carefully but very quickly. Look at the question. What they ask is, a ball dropped freely taken zero point 0.2 seconds to cross the last 6 meter distance. Okay, so this is zero point 0.2, the last 6 meter distance before hitting the ground. Okay, then the total time of fall is, okay, so they have provided with that's in u equals to 0. And if this total journey was of t seconds, then this would be a last 2 seconds of the journey, and within this last 2 seconds I have been traveled for the 6 meters. So what I need to find out is I need to find out the total time of fall. So g should be equals to 10 meter per second square. As they have given me the freedom, I'm going to use it. So what can I do? What can I do? Yes, what can be done? So what can you do is that, let's say this is h, and if I talk about the whole journey, it's in h plus 6. So I can write like this: h plus 6 is equals to half into g into t square. This could be considered as a relation number 1. H plus 6 should be is equals to half into g into t square. And one more relation, h is equals to half into g into t minus point of 2 whole square. This is the relation number 2. Yes, these two relations I can have. These are the two relations which can be used. Are you sure with this? Yes. Are you? Yes. Now what can I do is, if I take a ratio of this, it is an h plus 6 is equals to half into g into t square, divide by h is equals to half into g into t minus of point 0.2 whole square. So if I take ratio of this 1 by 2g, this 1 by 2g would be a gone, and the terms will be h plus 6 into bracket t minus zero point 0.2 whole square should be is equals to h into t square. Yes, this is relation number 3. What you can do is you can just expand it. And solve this. Yes, I think this numerical part can be done by you. So solve this and find out time t. Yes, I hope this can be done. This is only the mathematical calculation that I have left with. Yes, so without wasting a time, let's move to the next question very quickly. Yes, it is a question of water tap. It is one of the most favorite question of all the examiners. So please go through the data very carefully. What they have given. What they have given is that water drops falls from the tap on the floor 5 meter below at regular interval. Okay, so this distance is 5 meter. The first drop strikes the floor when the fifth drop begins to fall. It's a first, second, third, fourth, and fifth. Okay, the height at which the third drop will be from the ground. Yes, from the ground will be from the ground. So you are interested in this distance at the instant when the first drop strikes the ground. Okay, so first in this situation I have already given the diagram, but when this kind of questions will be asked in examinations, you need to prepare a diagram for this. So when you prepare a diagram for this, you must always consider that it is the first drop which is at the bottommost point, because it is always a first drop which is living, not a second drop or a third drop. So first drop would be at the ground, and the consecutive drops would be there in the air, and someone would be there which is just leaving from the tap. Yes, so this is the first drop. What we made a mistake is that sometimes we made this as a fifth, 4, 3, 2, 1. We are saying illogically that fifth drop has been fifth drop is at the floor, and first drop is just living, which is simply illogical. But we made the mistake, so please don't do it. Now, what can I do with this? What can I do with this? So let's begin. That this is water tap, and this is the height of 5 meter. Yes, this is the first drop. First, second, third, fourth, fifth. They are asking for this. They want this. Now, now, what all I can have is that u would be equals to 0. They are traveling under the effect of gravity. That means a is equals to g, which means it is a constant. One more very important thing they ask is that it is flowing at regular intervals of time. So probably I don't know the time, but I know that this time slots were same. So remember the Galileo. Yes, and the things will be done. Yes, this should be x. This should be 3x. Should be 5x. Should be 7x. And this all total would be a 5 meter. So what it would be? What it would be? It's a 7x plus 5x plus 3x plus x. 7 plus 5 12, 12 plus 3 15, 15 plus 1. It's a 16x. Should be equals to 5. So x is equals to 5 by 16 of meter. Now you have been asked that find out third drop will be from the ground at the instant. So you require a distance of third drop from the ground. So if I have seen the diagram, it's a 5x plus 7x, 12x. So this 12x should be is equals to 12 multiplied by 5 by 16. If I solve this, it's a 4 threes are, and this is a 4 fours are. So if I cancel this to, it's a 3 into 5, 15 by 4, 15 by 4, it's a, so 15 by 2, it's a 7.5, and again it would be divided by 2. It would be approximately 3.75 meter something. Yes, and this would be the answer. I hope these things are clear to you. Is it? Yes. So just quickly revise this. I have been given the height from the water tap, and just I have made the diagram that this could be the first drop, this could be the second, third, fourth, and consecutively. Then find it out the distance, and once I can have a value of this kind of x, then I can find out the distance of any drop. Whatever they want, that can be calculated very easily. Yes. So let's do one more question. Let's do one more question of water tap. Let's have a look at that. Go through this very quickly. What they have given. They tells me that water drops fall from a tap of height 1.6 meter at a regular interval. So this height has been given. This height has been given, and it is a 1.6 meter. If the first drop touches the ground, it's a first. Fifth drop just deattaches from the tap. Then time taken by the first drop. Time taken by the first drop to reach the ground. Yes, they want that what should be the time of flight of this first drop. So what can I do is that let's assume that this is time t, this is time t, this is time t, and this is time t. So this 4t time has been used, 4 into t time has been used for first drop to reach from this position to this position, and this height is given. This height is given 1.6 meter, as well as they told me that water drops falls from a tap. It's when u equals to 0. So what can I do is I can write like this. It's an h is equals to ut plus half gt square. And in this relation, if I put a u equals to 0, then I can have its h is equals to half gt square. So I have put up a value. It's a 1.6 is equals to half into g. It's a 9.8 into t square. So if I solve this, it's a t is equals to root of under root of 2h by g. And as on an answer, I can have it. This is 0.57 seconds. This is the answer. Yes? Are you done with this? Are you? Great. So, ready to move the next question? Shall we? Okay, let's go for it. What they have given. Look at this. A freely falling body covers 44.1 meter in the last second of its journey, and you require to find out the total distance traveled by the body. What can be done? What can be done? They say that it has traveled this much amount in the last second of its journey. So, if I write the relation for the nth second, what I can have is it's a u plus a by 2 into bracket 2n minus 1. If I put u equals to 0, if I put u equals to 0, then what I can have is this u should be equals to 0. So this is s nth equals to g by 2 into bracket 2n minus of 1. So this is s nth, and as said that it is in the last second, so it is the distance traveled in 1 second of that time. It is a distance traveled in 1 second of that time. So if I replace a value that this would be a 44.1, and if I solve this, it's an n. I am required to find out the distance, that value of an n. So let's solve this. So find it out an n. 44.1 multiplied by 2 divided by g and plus half. That if I solve this, then I can have is n is equals to 5 seconds. I can have is the n is equals to 5 seconds. So that means I have been traveling from u equals to 0 to this t is equals to 5 seconds. I have traveled for the 5 seconds. Now what I require the total distance traveled by the body. I can have this s is equals to half gt square, and if I put up a value, it's a half into 9.8 into 5 square, so it would be a 122.5 meter. This would be the answer. What was yours? Is it the same? Did it? Great. Let's move on. Next question. What they have given: a body thrown up with some initial velocity reaches a maximum height of 50 meter. Okay. Another body with double of the mass thrown up with double the initial velocity will reach a maximum height of. Okay. So what they requires that maximum height to be find it out, and the second body is having a double of the mass and double of the velocity as well. So first thing what we must know is the speed of the body projected is independent of the mass, because if you remember this, it's an h max that would be is equals to u square by 2g. So this depends on the velocity of projection. This depends on the velocity of projection, and this depends on the g. It's an acceleration due to gravity. Yes, but even in this motion in a straight line, we generally assume that g remains the constant. So it means h max depends on u only at this point of time. So what can I do is that let's say this is the second situation, this is the first situation, this is equals to u2 whole square, this is equals to u1 whole square. I require to find out this h2 divided by h1 is given to me, it's a 50. Now u2 is twice of u1 whole square divided by u1 square. So this is equals to h2 by 50. should be is equals to 4u1 square divide by u1 square. This should be a cancel out, and when this 2 should be a cancel out, then I can have is h2 should be is equals to 50 multiplied by 4. So this should be a 200 meter. This should be the h max. I hope these things are clear to you. Yes, this is 200 meter. Is it? What was yours? Is it the same? Is it same? Could you do it? Are you sure? Can it be done within time frame of 1 seconds or 1.5 seconds at max? Sorry, 1 minute or 1.5 minutes. Sorry, my mistake. Yes, could it be? Great. Shall we move to the next question? Shall we? Let's move on. What they have given. Go through this very quickly. What they have given is if the distance traveled by a freely falling body in the last second of its journey is equal to the distance traveled in the first 2 seconds. Okay, the time of descent of the body, you require a total time. So what you can have is you need to find out the distance traveled in last 2 seconds of his journey is equals to the distance traveled in the first 2 seconds. So that is s nth. S nth is equals to a by 2 into bracket 2n minus 1. Yes, so this is g into n minus half. G into n minus half, as its acceleration is equals to g only, and that should be is equals to half gt square. Now it is equals to the distance traveled in first 2 seconds. So let me replace the value of this half g, and time t should be is equals to 4 seconds. So if I replace this 1 by 2 into g into 4, it would be a 2g. So what I can have is that n minus 1 by 2 is equals to 2. So if I solve this, it's an n is equals to 2 plus half, and this 2 plus half becomes a 2.5 seconds, and the things will be done. That's it. Yes, can it be done? Are you sure? Now let's move to the next question. Very good question and very good application as well. Go through this very carefully. What they would ask is a ball dropped from a point P crosses a point Q in t seconds. The time taken by it to travel from Q to R. If PQ is equals to QR, that means they have dropped this from this position. Let's say this is P, then this Q, and then this is R. This distance is X, even this distance is X, and they provided that this is the time T. You require this time, that's X. So this time, sorry, I should write it as a T dash because X already been used. Yes. And one more thing, yes, very important. A ball is dropped. That means they have provided me that u is equals to 0. How can I do this? How can I do this? First thing, does this situation having the same time? Does this situation is having the same time? If you are thinking yes, then you are absolutely wrong on this. This are having a same distance, not a same time. So I cannot apply a Galileo's rule or a Galileo's law of odd numbers to here, because here the distance is same, not the time. Here distance is same, so I can say this is almost a reverse kind of application from the Galileo's law of odd number, because here also u is equals to 0, acceleration is constant, which is a equals to z, but the distances are same, while the time would be a different. In Galileo's law of odd number, there were distances were different. Remember, x, 3x, 5x, 7x, but the time were the same. So I need to take an help. I need to take a help from the basic relations of motion under gravity, and probably I will find a way. So let's begin with this. What I can have is, if I am talking about only this, then x is equals to ut plus half gt square. I am having an u as a 0, so what I can have is it's x is equals to half into g into t square. This is my first relation. Now, if I consider my journey from this position to this position, then what I can have is it's in 2x is equals to half into g into, it's a t plus t dash, it's a t plus t dash whole square. This is the second relation. So I am having with two relation, it's an x and 2x. Now what can I do? Let's let's take a ratio of this. Let's take a ratio of this, that this x is equals to half into g into t square, and this 2x is equals to half into g into t plus t dash whole square. So this would be a cancel out. 1 by 2g, 1 by 2g would be a cancel out. So what the things would be, that t plus t dash whole square should be is equals to 2t square. So if I take a ratio of this two, if I take a ratio of this two, it's t plus t dash. Let's take a square root of this, equals to root 2 times of t. So I am here to find it out the t dash. So my t dash would be equals to, it's a root 2t minus of t. So this is equals to root 2 minus of 1 into t. So what I can have is t dash by t should be is equals to root 2 minus of 1 is to 1. So this is the value. This is the value of the t dash, and this should be the answer. Yes, got it. Yes. So let me give you the shortest approach of this, and it's a trick. So what you can do is, let's say this is u equals to 0, this is distance x, this is again distance x, this is again distance x, and so on. Let's say here the time would be t1, here the time would be t2. Now you are aware that this times would should be a different, this should be a t3 and onwards. So if I need to find out the ratio of this, t1 is to t2 is to t3 and so on. So if I require a ratio of this, it's a t1 is to t2 is to t3 is to t4 is to t5 and so on, then I can have it, it's a 1 is to root 2 minus of 1 is to root 3 minus of root 2, it's root 4 minus of root 3. I hope you can understand the pattern behind this. Root 5 minus of root 4 and onwards. This would be go on. Yes, I hope these things are clear. Yes, so this can be done. This can be done when they have asked me. When they have asked me that for half of the distance they have taken this much amount of time, what should be the time required to complete the remaining half of the journey and something like this. Because they will talk about the distance they have traveled, they will talk about the distance they have traveled, and then you need to assume that this times will be different because distances are the same. So are you sure? Can it be done? Can it be done? Would you like to see one question based on this principle? Do you? Yes. So let's begin with this. Let's begin. what they have given is that an object is dropped from certain height h if first half of the distance can be covered in 10 seconds. Find out. Time required to complete another half. So this is the question. You have been provided freedom that you can take g is equals to 10 meter per second square. Now what can you do? This is the situation. This is the h, and that has been divided into two different halves. As they have been divided in two different halves. This is the distance h by 2. Again, this is the h by 2. And for this first journey, they have given that it is a 10 seconds. And you require a time for this. So what you can do is, look at this. It's a u equals to 0. Acceleration equals to g. That means it is a constant. And these two distances are same. They are the h by 2, h by 2. So you can have the trick that we have used in previous question. You can use it. And the things can be done. So let's do it. That first distance. This first distance is has been traveled in t 10 seconds. So this is t1, or rather I should say as a t2 is to t1. t2 is equal t2 is to t1. It's a root 2 minus of 1. So t2 should be is equals to root 2 minus of 1 multiplied by 10 seconds. Root 2 is 1.414. Let's say 1.41 minus of 1 into 10. So 1.4 t2 should be is equals to 1.41 minus 1. It's a 0.41 multiplied by 10. So that should be is equals to 4.1 seconds. Yes, this is t2. If they have asked what should be the time of flight of complete journey, then I can have a 10 seconds plus 4.1 seconds, and 14.1 seconds would be the answer. Yes, can it be done? Are you sure? Yes. So can you do this kind of questions? Can it be done? Are you sure with this? Can it be? Will you able to do this? Are you pretty sure with this? Are you? Okay. So let's move on to the next question of today's class. I hope these things are clear to you. And let's move on. Yes, this is another favorite question of examiner. It's a question of juggler. I hope you understand what juggler means. Do you? Yes? No? Don't you? Yes, you know the juggler. Yes, you might have gone through the circus, and there are certain person which are throwing sticks and balls in air, and he has multiple balls in his hand, and he is playing the tricks. Yes, he is the juggler. What our question says is that a boy throws n balls per second. So within a 1 second, let's say within a 1 second, he is going to throw the n number of balls. Yes, within a 1 second, he is going to throw n balls at regular time intervals. This is very, very essential. When the first ball reaches the maximum height, he throws the second one vertically up. What they ask is they ask that maximum height reached by each ball. So the situation would be something like this. He is having an n number of balls. He is going to throw n number of balls per second, but he is just releasing this one when the previous one is at the maximum height. So at this height, I know that final velocity of this ball at this height, final velocity of this ball will be 0. And if it is 0, what I can write is it's a v is equals to u minus gt. V is equals to u minus gt, and I know that it's an n number of balls per second. So in t seconds, it would be an n 1 by n number of balls. So this is equals to 0 is equals to u minus g into 1 by n. So what I can have is u is equals to g by n. U is equals to g by n. Now, if I want to find out the h max, I know that h max is equals to u square by 2g. H max is equals to u square by 2g. So if I replace this u would be equals to g by n whole square divide by 2g, and this will give me a g by 2n square. I hope these things are clear to you. Does it? Does it? Can you do this? Are you sure? This is the h max that each ball having. It's a g by 2n square. Yes? So let's wind it up here. These are the certain applications of motion under gravity. These are the certain applications. But this is not an ending up here. This is not ending up here. Yes, before you go to the next class of the same topic, please revise this very carefully, as well as please do as many questions as possible. Please do it. Only the practice can save us. So let's sign off. Thank you. Bye bye. Have a good day. Take care.